toward the end of previous session, we started to develop a new model. We called it Furniture Factory, Multiple Locations and Entities, okay? So please have that model open. So all of you created 5 locations and 4 entities and 1 arrivals, right? And we wanted to do the processes together. So we are all on the same page up to this point. So now, as you can remember, the logs go into the receiving dock and the logs come out and then they go to the splitter cell. Each log is splitted into 2 pieces, Then pieces go through the lathe machine one by one. They come as round leg. The round leg go to the paint booth and they come out as painted leg, and then they go to the painted leg store and then they come out. So we want to put this process together. And the difference that between what we are going to do here and the previous models is that obviously we have more than 1 locations and we have more than 1 entities. And we want to see how our entities can change form throughout the process. Okay, so these are my locations, my entities, my arrival, and then we want to do the processes. Okay, for the processes, I'm not going to do the click method, which is the easy method, simply because we want to pick the entities. So the first line. So the entities that are already at receiving dock the logs that are already at receiving dock, that's what we specified in the arrival. They are going to go to the splitter cell. So the logs are going to come out and go to the splitter cell. So the entities are logs and they are already at receiving dock. Logs are going to come out and they are going to go to a splitter cell. Next. What is the entity in our hand right now? The logs are the entity. So if you want to know where to start in the next line, always check where you ended up in previous line. In previous line, I have logs that are at the splitter cell. So that's where I'm going to start with. I have logs that is at the splitter cell. They're going to be split into what? So what is the entity that is coming out of splitter cell?
The pieces.
Pieces are going to come out in the destination side. Pieces are going to come out. And where do they go?
The lathe.
To the lathe machine. Okay. So logs that are already at the splitter cell get processed. And what is going to come out are pieces that are going to go to the lathe machine. So what I want to also do right now is that from 1 log goes in and 2 pieces come out. So how do we do that? Here on the destination, when the pieces come out, if you click on the rule, this window opens, and here you see quantity. If you change it to 2, that will take care of that, which means 1 log goes in and 2 pieces come out. So for pieces, when they come out, if you want to say 2 pieces come out, click on the rule. And then in quantity, 2 pieces come out. Press OK. Now, how about the processing? Okay, do I have any processing time at receiving dock? Should I write anything here?
No, there's nothing.
Okay, how about splitter cell?
N31.
Okay, what is the complete statement?
Wait, N31.
Wait, N31.
Does it matter if you capitalize it or leave it lowercase?
It's all, both of them are. Next line. What is the entity in our hand right now?
Pieces.
Pieces. Where are we?
Lathe.
Pieces went to lathe. So pieces at lathe machine. What is the entity that is coming out of lathe machine?
Round legs.
Round leg. And where does that go?
Paint booth.
It goes to the paint booth. Okay. Any processing time on the lathe machine?
Yeah, the T369.
I'm not putting minutes next to any one of them because the default unit of time is minutes, so I don't bother. Okay, next line. What is the entity in our hand?
Round legs.
This is where we ended. So where we ended up with round legs. So we start with round leg. Where are we? We
Paint
ended,
booth.
yeah, we ended with round leg at paint booth in previous line. So we start with round leg at paint booth. And then what is going to, okay, we round leg, which is at paint booth. What is coming out?
Painted log.
Painted log. And then where does it go?
Exit.
No.
Oh, leg store. I'm
Into
sorry.
leg store.
Yeah. Painted log comes out and it goes to painted leg store. Any processing time at paint booth?
Wait E5.
Exponentially 5.
Okay. Exponentially distributed 5 minutes. Okay. So we ended up with painted leg at painted leg store. Next line. What is the entity in our hand?
Painted leg.
Where are we?
Leg store.
Leg store.
And what is the entity that is coming out?
Painted leg.
Where do we go?
Exit.
We exit the system.
That's it.
Do we have any processing time on painted leg store?
No.
No. You just go there and then just leave the system. Okay. So yeah, so if you are taking care of operations when one entity goes in and another entity comes out, not a problem. So just make sure that you have your operations carefully specified, the entity that goes in, the entity that comes out, the processing time. If one entity goes out, but 3 entity goes in and what 3 entities comes out, make sure to, you know that, you can specify that in the rule quantity box. I think everything else is set for now. Let's run the simulation for 2000 hours. Run for 2000 hours. And here you see entities going and come out. So here again, I told you in previous session, but it's important to know this, guys. So you see here, hours 25, 26, up to 2000. That's a lot of time, especially if it's in your exam. You don't want to waste that time. So animation here, you can turn it off. Right now, it's highlighted. That means it's on. So if I want to turn it off, I just click on it. The rest goes fast. And you get the results, so you don't need to wait that long. Okay. So here you see, finally, I have the painted leg as total exit is about 14,000. Are your numbers close to 14,000?
Yes.
Okay, great.
Yeah.
So yeah, so the other entities, because they were transformed to other entities, so I don't see any exit related to those, but for pointed leg, I see this number of exits. The total time that the painted leg has spent in the system is about 23 minutes. And also before, let me also mention that here, sometimes you may come here and then you see that, oh, for example, I don't see any information for logs or pieces or so. So always pay attention to the left side. You see here items, these are your entities. So if you check or uncheck them, you see their informations here or not. So sometimes if you don't see the information related to some of your entities here, always make sure to double check here and make sure everything is checked out for you. And okay, so what is I want to look at the utilization of some of these machines. What is utilization of a splitter saw? What percentage of the time splitter saw has been busy?
We go to tables and then locations, right?
Tables, location summary. Okay. What is the utilization of the splitter saw?
70%.
About 70%. This is the column. What is utilization of the paint booth?
58, 59%.
58, 59%. For the painted leg store, because there's no processing time there, you just go in and go out. There's no utilization, obviously. And for the receiving dock also, there's utilization doesn't mean much because it has capacity of infinity. It can hold infinite things. So there is really no full capacity ever. So that's why we don't see any meaningful number for those scenarios, but for the rest of them, we see those numbers. So what I wanted you guys to do, please go back to, so let's look at this here, for example, the lathe machine. Its utilization is 85%. Let's go to the report. And you know here also is about locations, right? Also, I want you guys, before I continue with what I wanted to tell you, I also want you guys to pay attention to the titles here. Single capacity locations, multiple capacity locations. When we define the locations, we put capacity of 1 for these locations, and we put capacity of infinity or something greater than 1 for receiving dock. So in this basically dashboard, they put all the single capacity locations in one side and all the multiple capacity locations in another side. So there is no difference between them, but just so you know, these two are separate in this dashboard. And for the lathe machine, can you also just tell me what is the utilization by using this window?
70.5% operation percent.
Okay, so you came here, when you move your cursor on top of the green part, it says percentage in operation, 70%, about 71%, okay? So then if I ask you, what is the utilization of the lathe machine, what would you say, 70%? Is that your number?
Yes.
Okay, however, when I go to the location summary for the lathe machine, the utilization has been reported as 85%. So what is going on here then? What is the reason for this discrepancy between the
It
numbers?
looks like they're adding the block time to it, or they're either adding the block time or the idle lathe percentage.
Okay.
Right?
So definitely not the idle one. Idle is when the machine is really doing nothing. Okay, so the machine doesn't have any entity to process. However, when we look at the numbers, we see that it's actually the percentage, when we add the percentage of operation and the percentage of the block time, then that's the total we see as the utilization in the location summary. So that's 70% plus 15% of block time is the 85% of the utilization that we see here. So now, this is my question. We talked extensively about what block time means for entities, right? When entities wait to get processed, what does block time mean for them when they are the first
Customer
entity
line.
in the line? So we know what block time means for entities, but what is the meaning of block times for the locations? Late machines is a location, it's not an entity. What is the meaning of block time for a location?
Is that when the process is finished, but the entity can't move on?
That is correct. So when late machine has an entity, it finishes processing the entity.
That station.
Do you hear me, guys?
No.
No, ma'am.
Do you hear me?
Yes.
Yeah, I can
Yes.
hear you now.
You cut off, but you're back now.
Okay. Okay. So what I'm gonna tell you is that what is the meaning of block time here? Okay. So you see here, there is no queue between these locations, right? So when late machine is done with processing a part, all it can do is to send the part to the paint booth. However, if the paint booth is busy processing another part, late machine cannot put a part aside in a pallet, in a queue, anywhere. They have to keep the part till the part in the paint booth is out, then they can send the part to the paint booth. So the late machine is done processing, the operation is done, but they are blocked with the next machine because next machine is busy, they are blocked and they cannot send the part out so that they can start working in another part. So that time is considered as the block time for the late machine. The machine is done, but it has to just hold on to the part until the paint booth person is done, and then they can send the part to the paint booth. That time is considered as the block time for the late machine. So that's why we don't want that to happen. That's why we do want to have queues, some waiting areas for these parts that are done in each one of these machines, so that when they are done, they just put the part in that waiting area and then they start processing another part. Okay, so then when we look at these arrays, then 70% the late machine is working. The other 15% is not working, it's just holding the part. So that's not a good utilization, I would say. However, in the location summary, it just reports the sum of both of them, 85%. So in your project, in your work in the future, in your consulting jobs, in your everything you do, be mindful of these numbers. The utilization that is reported in the location summary is the sum of the operation time and block time. If you want to get a better sense of how much of it is actually operation and how much of it is block, come back to this graph and see how they work. If the machine is blocked a good amount of time by the next machines, that's not good. Find a way to get rid of the block time, because we want the machines to be in operation most of the time, not blocked and not being able to do anything just because they have to hold on to a part because they can't leave it aside. Okay, so be mindful of these numbers. If I ask you, go ahead.
If we have a conveyor or a waiting area, these numbers would change, right?
Yeah. If you have a waiting area, then the block time will go to 0, because then as soon as late is done, immediately it puts the part on the waiting area with a capacity of, let's say, infinity, and then it starts processing on another part. So we don't have a block time there.
Sir?
Yes.
Can you go to the location summary table, please? Under the average contents here, are these the number of the quantities of the like the quantity of products that are being produced from each?
These are the average of the contents that have been in each one of the in each one of the operation, in each one of the locations. For example, for the paint booth, can you tell me or for the lathe machine, can you tell me what are some of the possible values for the content of the lathe machine?
0, 1.
0 and 1. Okay, 0 or 1. Now, can you also tell me why the average content is, so you said the possible values for the content is 0 or 1. Now, can you tell me also why the average content is not just average of 0 and 1, which is 0.5, and why it's 0.86? So what happens here is that so let's say the simulation. Initially, there is no entity in the machine, and then one entity comes, and then as soon as that one is gone, another one comes, and then immediately another one comes, these are all late machines, okay? And then this one is done, and then no entity is there in the next minute, no entity is there in the next minute. In the next minute, another entity comes in the next minute. Or when we look at the content, there is one. There's still one entity in there. There is still one entity. So when we look at the average content, is the average of these numbers over time. When we look at the content, is it 0 or 1? 0 or 1 is the average of these numbers. And if more of that time there is one entity is there, then the average is more than 0.5. Then if most of the time no entity is there, the average is less than 0.5. So the average that we see here is not just a simple average. Where is it? Is a weight average. And what is the weight? Is the percentage of time that we have had 1 and the percentage of time that we have had 0. So if I want to look at the average, I'm just saying 0 plus 1 divided by 2. No, I just say, okay, I had 0, but only 25% of the time. And then I had also 1, but 75% of the time I had 1. And then I report that as the average of content. So the possible values of the content are 0 and 1, these two. But when I do this method, it's equivalent of this 0 multiplied by 0.5 plus 0 multiplied by 1. Okay, so the two possible values are 0 and 1, but I give the same weight to both of them, as if both of them happen the same amount of time. However, here, this is not the case. The two possible values are 0 and 1, but they don't happen the same amount of time. 0 happens less, 1 happens more. So the weight that I'm going to give them is 25% and 75%, or whatever it is. Again, this is going to be a weighted average. Okay?
Mhm.
And the numbers that we see here, they are weighted average of the content. We look at possible values of the content and look at average of them. And then in this average, we use the weight. Let's assume I had another location, and this location would get 3 possible values for the content. It would get 0 or 1 or 2. Okay, 3 possible values. The location could hold 2 entities. So sometimes there is no entity, sometimes there's only 1 entity, sometimes there are 2 entities. And 25% of the time there is 0. Let's say 50% of the time there is 1 entity, and then 25% of the time also there is there's 2 entities. Okay, so if I ask you what is the average content of that location, you don't just say 0 plus 1 plus 2 divided by 3. No, you calculate a weighted average. And the weight that I'm giving here to these numbers is the percentage of time I have observed 0 entity in there, or 1 entity in there, or 2 entities in there. And the number, whatever it is, I don't know exactly what is going to be the number, but the number, whatever it is going to be the average, weighted average of the content of that location. All the numbers you see here for the content are the weighted average. Does that make sense?
Yes, it makes sense. Thank you so much.
Sure. Okay. This was actually a good question. So it's important for you guys to know these concepts and how these numbers have been created so you can make sense of them. Okay.
So if a question asked, like, on average, how many pieces they were waiting or in the lathe, and that would be the 0.86.
Exactly, 0.86%, which here is actually the same as utilization, because when a part is there, that's when the late machine is utilized, right? So that's why these two numbers are close or basically are the same in this example. However, if it's the queue, when I ask you on average how many entities are waiting in the queue, you can again come here and look at the average content of the queue. In that scenario, obviously it can be 0, 1, 2, 3, 4. It can go out to as to any number depending on what you specify as the capacity of the queue. Then the average content of the queue tells you on average how many entities have been waiting in the queue during the simulation time. You can look at those. For example, here for the receiving dock, obviously it has been the minimum is 0, but at some point there has been also 4 entities waiting in the receiving dock, but the average content is 0.15, which means this happens very rarely. Most of the time it has been 0 or 1 or close to those. That's why the average is such a small number, although the maximum is 4. Just because it has happened maybe once or twice during the whole simulation time. And how about the current content? What does that mean?
It means how many are in the system at the moment or in the process at the moment.
What do you, when you say the moment, which moment you're talking about?
When at 2000 hours.
When we stop the simulation, exactly.
Yeah, exactly.
When we stop the simulation, what is the content of these locations? When we stop the simulation, there is still one entity at the late machine, and there is still one entity at the paint booth being processed. They haven't left the system yet. That's where they are. There's no entity in other locations, but in these 2 locations, there are 2 entities that are still waiting. And that's fine, because we don't have any specific condition for the terminating the system other than the time. So when I say stop after 2000 hours, then the simulation stops after 2000 hours. It doesn't care if there are entities here in the locations or not. It doesn't matter. We will learn also how to tell the simulation to continue till every entity that has come to the system is out. We will learn how to do that when we learn to model systems such as supermarket, barbershop, things like that, where they close the system at some point, but they still continue working till everyone in the store is out. We will learn how to model those systems. In those scenarios, we will make sure that at the end, when we stop the simulation, there is no entity in the system. But so far at this point, when we just say simply run the simulation for this number of hours, there's no rule. So when we stop the simulation, it's absolutely possible that we have some entities under process at some of these locations, and that's fine. So I'm in the folder for week 3. At the end of the name of the model, add locations. At the end of the name, put dash, add locations, and save it in the folder for week 3. What I want to do now is to add an oven between paint booth and painted leg store. Here. Between these 2, I want to add an oven. So after the part is painted leg is coming out of painted booth, it goes to oven, it gets processed there, and then it goes to painted leg store and then leaves the system. No big deal. We just want to see, okay, you have a model, but at some point you figure out, oh, I actually need to add a location. How do you deal with it? You need to modify your model. That's something that will happen for sure a million times in this class. So you develop a model, but at some point you need to add a location, add an entity, things like that. How do you modify your model? So so the change we want to make here is that when the painted leg comes from paint book, it goes to oven, gets processed, and then painted leg comes out, goes to the painted leg store, and then leaves the system. And there's a processing time of 5 minutes, exponentially distribute. No, I'll give you the processing time in the oven later when we do it together. Okay, so I'll give you the processing time in the oven later. So that's all we want to do. Let's go to, what do we do then? Where should we start with?
Build.
Location.
Locations. So
Location.
let's add a location for the oven. Leave the capacity as 1. Make sure to put the label. Make sure to save. Then go to entities. We don't make any change in the entities in the arrival. Do I need to make any change in the arrival?
No.
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 Okay. For processing. Logs go from receiving dock to splitter saw. Perfect. From splitter saw, they go to the lathe. Perfect. From lathe, they go to the paint booth. Great. Then from the paint booth, they go where? They come out of the paint booth. They don't go to the leg store. Where do they go?
Oven.
To the oven. So then in the 4th line, when the round leg is at paint booth, they get processed. Painted leg comes out, but it doesn't go to the store. Just click on the destination and pick oven. They go to the oven. So then painted leg goes to the oven. What happens then? Then I need to add 1 line for processing at the oven. So go to the very end, press enter so you have a new line. Okay, so where am I? I'm at oven. And what is the entity at oven?
Painted leg.
Painted leg is the one that is at oven. And what is the entity that is coming out of oven?
Painted leg.
Like,
The same painted leg comes out. And where does the entity go?
Painted leg store.
To the store. Okay. The processing time at oven is normal, average 20, standard deviation 2. Processing time at oven is normal, average 20, standard deviation 2. Make sure to enter that. Okay, so right now the painted leg is at the store. Where does the entity go from there?
Exits.
So then I need a line that says painted leg, which is at the store, goes exit the system. Do I have that line already?
Yes.
It's this line. Painted leg, which is already at the store, is going to exit the system. Okay, so I don't need to add an extra line. I already have the last line that I had at previous model is still valid. I can keep it. So what happened here is that because I added an entity, a location, so the entities that previously went from the paint booth directly to the store changed the route. They went from paint booth to oven first, and then from the oven to the store, and then they left the system. So then I just need to come find the flow, find which line I need to change, and just create new lines if I need to. And that's all that there is into it. So my question for you guys, does the order of these lines matter? The fact that here I have the oven to leg store as the last line, and I have the store to exit at 1 to the last line, does this order matter in the simulation?
No, it just bothers my OCD.
Yeah. I was wondering if you can move the lines just if you're checking a
Yeah.
bunch of processes.
Yeah.
And if you want to have them in order.
Of course. So sure. The important point is that the order does not matter in the logic of the simulation. Simulation just follows the logic. Simulation says, okay, paint booth, the left round leg goes to paint booth, and then painted leg comes and goes to oven. Okay, next line, simulation wants to know what happens at oven. So the simulation comes here and say, okay, where is the line where the same entity painted leg is at oven? Okay, the simulation runs this line and say, okay, so where does it go? It goes to the painted leg store. Okay, now simulation wants to know what happens when painted leg is at painted leg store, comes here again and looks for the line where painted leg is at painted leg store, and then goes to wherever that takes the simulation. So the order of these in the logic of the simulation does not matter, but I agree with you. When we have a big model, we do want to see the correct order so that we can figure out the mistakes or make sure things are correct. Or if you want to explain it to a customer, you don't want to go all over the places to tell them, oh, we go here and then we go there. Like, you want to have it nice and easy. So if we want to make that change, what we need to do, so for example, for the last line, I want to bring it one more up, right? So right click on the line. First, I pick move, and then I go to the line that I want this new line to be moved to, and then I pick. So pick the line that you want to move, right click, choose move, and then go to the line that you want this line to be moved to, right click, and then pick move to, and then it will be moved. So let's assume I want to move the oven line to the first line. Right click on the oven line, pick move, go to the first line. That's where I want this line to go to. Right click, move to. So oven line came to the first line. I want to bring it back to the fourth line. What is it? Yeah, to this line, after paint booth. Pick oven line, choose move. I want it to come here, right? Right click, move to, yeah, it just moved to here. Yeah, so with right click, move and move to, you can do what you need. If you are using the 2016 version, all of these options are in the edit menu. You can do the same, but you just have to go to the edit menu, pick move, move to, delete, anything you want.
Yes.
Also, let's also run and just see what we get. Make sure to turn off the animation too. Okay, you see we see a lot of more block time. So that's because we suddenly added an operation. See here, suddenly oven takes 20 minutes. Everything is such a short amount of time, done. Then suddenly such a long processing time of 20 minutes. That obviously blocks everything, right? The oven takes forever, then paint booth is blocked, then lathe is blocked, the splitter size blocked, and so forth. So that's why suddenly the block time increases in these machines, which is really not good, which obviously shows something is blocking your process. So you want to go see what it is, how you can get rid of it, and so forth. And suddenly from 14,000 exit, we came to about 6,000. Please open the Barber model, the first version. Okay, so the first version, I have a location for the arrival, capacity infinity, they go to the Barber and then they leave. Arrival, I have it as E10, and then the processing, 9 minutes, okay? And we ran that for 8 hours, I believe. Okay. I want you guys to please go back to this model, save it as a new model in the folder for week 3. And at the end of the name, put traffic intensity. Traffic intensity. Okay. So open the barbershop, the first version, the barbershop model, first version, Save it as a new model in the folder for week 3. At the end of the name, put traffic intensity. And in the processes, just for the simplicity, let's change the processing time to E. So on average, it takes 6 minutes to provide a haircut. In this model, what was our arrival rate? E10. What is arrival rate?
6 customers per hour.
Exactly. Arrival rate is 6. Service rate has the same unit, basically, that's what I meant. And service rate here is what? Service time is 6. What is the service rate?
10 per hour.
10 per hour. So it's 10 customers per hour. Traffic intensity, for those of you who had queuing theory or operations research with me, what is traffic intensity? Okay, so traffic intensity basically is arrival rate divided by service rate. That's what traffic intensity is, arrival rate divided by service rate. Now tell me that, now let's see what happens now. So this is my arrival rate, this is my service rate. Traffic intensity is the division of these two and it's 0.6, obviously. I'm going to increase my arrival rate to, let's say 8. 8 customers per hour. Then the inter-arrival time is 7.5 in this scenario. So I can just write it here for you guys. If the arrival rate is 8, then the arrival time will be 7, inter-arrival time will be 7.5. Then all I need to do in the model is come here and for the arrival time, instead of 10, instead of one customer coming to the system every 10 minutes, one customer is going to come to the system every 7.5 minutes. Okay. Before I run the simulation in that scenario, actually, let me go back. Sorry guys, let me change it back to 10. Oops. I have it as the original version. Inter-arrival time is 10 minutes. The processing time is 6 minutes. And I'm just running it. I'm going to take a look at a couple of things. Let's look at the utilization of the barber, 57%. I'm going to write it here just so we know. Okay, utilization of barber is 57, and then time in system for these customers is about 11 minutes. Okay, so let's have this. With the original scenario, this is the original service rate of 10. So that means 6 customers can come to the system at any point. So 6 customers can come to the system at any time. 10 customers can leave the system potentially at any time. This is the utilization of the barber. This is the time in the system for each customer. And this is what I call as traffic intensity. Now I want to change. Customers come to the system faster. In each hour, I receive 8 customers. But still, the system can process 10 customers. What is traffic intensity? Traffic intensity is arrival rate divided by service rate is 0.8. Okay. Now let's make that change in the model. Go to the arrival. You hear me, right?
We can hear you.
Okay. Let's go to the arrival. Instead of 10 minutes for our inter-arrival, let's change it to 7.5 because we just calculated that if I change the arrival rate to 8 customers per hour, that means inter-arrival time is 7.5 minutes. So keep the service rate as is, increase the arrival rate. That means more customers come to the system. Our traffic intensity went to 0.8, and let's run the simulation under this scenario. The location summary, the utilization of the barber is now 70%. and the time in system is 11.4. Let's increase the arrival to 10, rate of 10. So if the rate of arrival is 10, what is the inter-arrival time? You should say
6.
6.
6 minutes. Okay. So then I go back to the model. I change the inter-arrival time to 6. And then arrival service rate is 6 as well. Then I'll increase that. See, the utilization is now almost like 91%. Okay. So obviously those are the utilizations we don't want to have, because when when the service rate is also 10, traffic intensity is 1, and utilization is 91%. Okay. And the time in system suddenly went to 25 minutes. Okay. Suddenly went from 11 minutes to 11.4, suddenly to 25 minutes. Utilization went from almost 50% to almost 100%. Okay. And as you can see here, the traffic intensity has increased. The arrival rate divided by the service rate, it has increased from 0.6 to 0.8 to 1. So what does this mean? And this is a concept that also we deal with in the queuing theory. If the rate of arrival of the customers to the system, let's say if I go to 11 customers per hour come in, only 10 customers per hour leave and go out. What happens in this scenario? When we let the system to continue working over time, what happens to the system? When time goes to increases, the system continues working. What happens? What is your expectation? 11 customers come in, but only 10 customers go out per hour. What happens? What do you expect to happen to these systems?
You're going to have some block time and 100% utilization.
Okay, so what does that mean? So that means the number of entities in your system is going to go to infinity over time. Gradually, you have more and more customers waiting. So the number of entities in your system over time goes to infinity, as if the system is going to explode. Those systems are not meaningful to operate because there is nothing to tell about them. The time waiting in the system goes to infinity. The number of entities in the system goes to infinity. The number of entities in the queue goes to infinity. The waiting in the queue goes to infinity. There is nothing to say. There's nothing meaningful to say about those systems. So for the queuing systems to be meaningful, to be a rational queuing systems, to be able to analyze them and tell something meaningful about them, we want the traffic intensity to be less than 1, not even 1. We want the traffic intensity to be less than 1. Those are meaningful, rational queuing systems that we can talk about, we can say something about, we can potentially take actions to improve. But when the traffic intensity is 1 or above 1, there is nothing we can say about those systems. The waiting time in the systems, and the number of customers in the system gradually is going to go to infinity as we continue running the system. Okay, so just keep that in mind, that in any system that you want to analyze in the real world, in your homework, in your project, exam, anything, make sure to check that. We do want the arrival rate to be less than service rate. We do want the traffic intensity, which is arrival rate divided by service rate, to be always less than 1, not even 1. When the traffic intensity is 1 or anything greater than 1, those queuing systems are not rational queuing systems. The number of entities in those systems overnight goes to infinity. There's nothing we can say about them. There's other than hiring more people to make sure more people can get the service and leave, or finding a way to control the arrival rate. But other than that, there's nothing to mention. And also keep that in mind, that sometimes in your systems, maybe you are designing a system later in future, things like that, you can play with the arrival rate. with the service rates to get the right utilization and the waiting time in the systems and so forth. So we see the effect of this as more customers come to the system compared to this one. As more customers come to the system, obviously the utilization of the locations of the machines increased, the time waiting in the system increased. Obviously, this is a rational expectations from the behavior of such systems. So you can see how by changing the parameters, by changing the input to your model, you can change the behavior. And those are some of the what if analysis that you will end up doing later as you're using the simulation. Let me check